Suppose you're considering a career change. You see climate change as this big looming problem and you want to try to help tackle it. Now, you're trying to decide if you should work on, say, marketing solar panels, policy change, or if you should just pick one tree and make sure it lives forever. The problem is you can't predict the future. Your instincts say the tree thing might not have the biggest impact, but how do you know for sure? If I choose marketing, how many people will I reach? What impact would that have? With policy, what are the odds of changing a relevant policy? How much impact would that have? These are really hard things to put numbers on, and Fermi estimates provide a way to help solve these sorts of problems. It's called a Fermi estimate because Enrico Fermi used it to estimate really impossible to estimate things, like what are the chances that we're alone in the universe? We've learned that expected value can help us make better choices about how to have a bigger impact. As you remember, the expected value is the probability of an outcome times by the value or the impact of that outcome. But in many real-world situations, both the probability and the impact can be difficult to estimate precisely. This is where Fermi estimates come in. A Fermi estimate allows you to make a reasonable, educated guess about numbers that are hard to measure otherwise. By making some good assumptions and breaking down a big problem into smaller, more manageable chunks, you can get a good back-of-the-envelope estimate. We call it a back-of-the-envelope calculation because it's not trying to be perfect. If you're at work and your finance team does your taxes on the back of an envelope, then you might be in a Ponzi scheme. But when you're just trying to get a better estimate than merely plucking a number out of thin air, then breaking it down on the back of an envelope helps a lot. So let's say we're looking at this marketing solar panels idea, and you want to estimate the impact of your work. Using a Fermi estimate, you might assume your impact depends on a bunch of things. It might depend on the size of the market, the percentage of those people in the market who you could actually reach, the percentage of the people who you reach that might actually buy your solar panels, and the average reduction in carbon emissions per set of solar panels. By multiplying these estimates together, you can get a rough idea of the total impact that you could have in this role. We can also use these back-of-the-envelope calculations to gauge our chances of success. How likely am I to change a particular policy by, say, like a ballot proposition? To do that, I might look at the chance of me getting funding, the chance of getting enough signatures to get on the ballot, the chance of avoiding all the administrative hurdles that it takes to get on the ballot, and then the chance of winning voter approval at the actual voting day. With these numbers, you can make an informed guess about your likelihood of winning, much more accurately than pulling a number out of a hat. By using Fermi estimation, you can quickly make clearer decisions. It won't give you perfect answers, but it will take a fraction of the time from getting a perfect answer, and it's a much better place to start. If you're going to spend hundreds of hours on a project, it's worth spending a few hundred seconds guessing the impact on the back of an envelope.